Welcome to Math Cafe. Enjoy math sip by sip. Welcome to Fundamentals of Calculus or the topic Limits and Derivative. In this session, we are going to see what is limit of a function. And before going to the actual topic, and this calculus is one of the most fundamental topics in mathematics, one of the finest and most interesting branch of mathematics, and it uses everywhere in our daily life. Wherever you want to maximize or minimize any idea, whether it is a business, maximizing profit, when you are preparing for the examination, within minimum time, cover maximum topics. Anywhere you maximize or minimize idea, there comes calculus. And for the calculus, first we need to know about the limit of a function. Let us start with recalling what is a function. A function is y is equal to f of x, where x is the independent variable and y is the dependent variable. And as I told before also, y stands for u and ur depends upon your parent. Your parent is the independent variable. Any change in the mode of your parent certainly will reflect on u. That is what is actually we are calling this as a function. Consider some simple functions as y is equal to x or f of x is equal to x, and another one f of x is equal to x square and f of x is equal to 1 by x. Just we consider some cases. As x approaches to 2, what will happen to f of x? Obviously, when x approaches to 2, this f of x also will go into the value as 2. Similarly, here when x approaches to 2, this f of x is going to be 4. And here when x approaches to 2, this is going to be 1 by 2. If you draw a graph, it is very easy to picturize and you can see visually. See the graph here. When x approaches to 2, this y value is coming at 2. And here when x is equal to 2, this value is coming to y is equal to 2. And here when x is equal to 2, this is becoming half. If you recall here, when x approaches to 2 means this x approaches to 2. Maybe this is 1.2. And how can you reach it to 2? If there is only one path to reach it to 2 or 3 or how many paths will be possible? It's just like you are meeting at a point, your friends all meeting at a common point, maybe one of the attractions of your town, and there may be many roads will be there to reach at that one. So you will have always different paths to reach there. Now here we are considering real numbers. As you seen that real valued functions, we are not going to see all paths. And if you consider a complex plane, you will have many paths will be there. That all you will see in higher classes. For the time being, we are restricting our discussion. We consider a number line or just a straight road. If you are at the straight road at this point, maybe P, either you can come from the left of P or you can come from the right of P. Here if you see, you are coming from the left of 2, this value is coming close to this and y value reaching at 2. And if you are coming from the right of 2 still, the value will be coming close and you're reaching at 2. Similarly here as well, you are coming to 2 from the left or right, you will be reaching at the same point. This means you are approaching to a particular value. Usually we'll say like this, if you have a function f of x and if it is limit is approaching to 2, f of x will be written as like this way. And generally we will say if x approaches to a and if the function f of x is approaching to a value L, that will be represented as limit x tends to a f of x equal to L. You have to notice this one, you are writing LIM below x tends to a or x approaches to a f of x is equal to L, or we will write LT x tends to a f of x is equal to L. And here there is a major difference is there. F of a and limit x tends to a f of x, are they equal? You may feel that when you are calculating it will be the same, but in theoretically they are not the same. One value that f of a means in the function f of x, just instead of x you are plugging the value a and you are getting the value of the function exactly at x is equal to a. And whereas in limit x approaches to a f of x, it means you are approaching to a. It could be from the left or it could be from the right. Now we'll see that how do we check whether it is coming from the left or from the right. This is what our main takeaway from this topic. Whenever limit x approaches to a f of x, we write it as limit x tends to a f of x is equal to L, and this is not same as f of a or the value of the function at x is equal to a. Let us consider Another example, see this graph f of x is equal to 2x, 0 less than or equal to x less than 3 and x plus 1 when 3 less than or equal to x less than or equal to 6. Now suppose I need to find the limit x tends to 3 f of x. What could be the value of limit x approaches to 3 f of x? This is one most common question in limits, and if you can get this idea, you have done the limit part very well. And this generally we'll call it as one-sided limits. Now the first question or the primemost question is that when x approaches to 3 f of x, I have the graph as well as the algebraic value, both are there. Which one I will choose? Shall I use 2x or I should use x plus 1? If you can answer that question, you have done the limits and you got the idea. When x approaches to 3 f of x means the first graph says like you are coming along this path or you can come along this path, because this is what is the 3 value. Either you can come from the left of 3 and right of 3. And as we are using the real valued functions, when you are approaching to a particular value, you could come from the left and right. Now, do I need to find the left limit and right limit every question, or in which situation you find left limit and right limit? Listen, I will tell you very clearly where to be applied that idea very clearly. This is a situation. Now you know that limit approaches to 3, you can use either this or that, and you don't know which one exactly should be used. At this point of confusion, we have to think, do I need to go for left limit and right limit? Simply, if the function is breaking at a particular point, and if you are looking at the limit at that specific point, it says you have two options to approach that particular point, either from your left or from the right, and that clearly says you must use left limit as well as right limit. Simple idea. And if you know the graph very well, you know that as x increases through the value, you are coming along this path, whereas when x is more than 3, your path is totally different. So it clearly says you must use left limit as well as the right limit. And if you can check from here, when limit x approaches to 3, and we'll now go for the actual notation. If you're coming to 3 from the left, you're at 3 minus f of x. And please keep in mind, this 3 minus doesn't mean that negative 3. It just confirms that you're coming to 3 from the left of 3. Clearly, you are using this path. You reach it at 6. Now, this is called left hand limit, or we'll say LHL. It says you are approaching to 3 from the left of 3. Now, limit x approaches to 3 could come from the right of 3 also. There we will write limit x tends to 3 plus f of x, and if you can observe here, to the right of 3 you are coming across this way or along this path, and you reach it at this point 4. That is the value left hand limit as well as the right hand limit. And generally, as you can see here, there is a gap, and you are planned to meet at a common point, but both friends have reached to different destinations. They are not meeting each other. Clearly, the limit does not exist. The conclusion is this way. Left hand limit means always we will say it is limit x tends to a minus f of x. As you are approaching to a from your left of a, we will say a minus f of x. And if you are coming to a from the right of a, we will say limit x approaches to a plus f of x. And whenever this LHL and RHL are equal, in such a case we will say limit x tends to a f of x exists. Otherwise, it is not existing. As you plan to meet at a, both friends should reach at the same point, then only the limit will be existing. That is what is the basic idea of limit existing. If LHL is not equal to RHL, as you have seen in the previous case, the limit does not exist in such cases. So we'll say limit does not exist. I repeat, the left limit and right limit is required only when the value of the function is breaking at exactly at that point. The same question if you want to find, say, limit x tends to 1 f of x. Do we need to find left limit and right limit? Yes, you are correct. You don't want to, because the value of the function at 1 just before and after this is 1 and this is not breaking. This is a smooth curve. You don't want to find it. And if you are finding at 4 or 5, if it is 4 at here, again one single curve, it's not breaking, you don't want to. At 5 again, you don't want to. You need to find the left limit and right limit only at the point where it is breaking. that is the point at 3, that you can clearly see when the function is given in algebraic form. So we'll come back. What we have learned is this: whenever an x approaches to a and if the function is approaching to L, we will say it is limit x tends to a f of x equal to L, or LT x tends to a f of x is equal to L. This is what the fundamental idea of the limit. And whenever the function is breaking at a specific point a, we need to find both left limit as well as the right limit. Left limit means you are approaching to a from the left of a, and the right limit means what you are approaching to a from the right of a. That is what is the definition of limit. See, this is what the left limit. X approaches to 1 from the left of 1, and see it comes to close to 1, it is becoming 2. And if you see the next one, if x approaches to 1 from the right, it goes to another value. See the different graph, so it is breaking. This limit is not existing. Now here you see what is the value of y when x is equal to 1. X is equal to 1 means this is the value of the function. This is not limit x approaches to 1. This is just the value of the function at x is equal to 1. Hope you understood the idea of limits. In the next session, we will be checking how to evaluate the limits in different cases. Thank you for watching Math Cafe. If you enjoy the video, please like, share and subscribe.